We present a dataset of spoken words in 50 languages for voice interface and keyword search applications. Always-on voice assistants have become ubiquitous, but their wake word commands only consist of very small vocabularies in a limited number of languages. This is because training a keyword spotting model requires thousands of examples from many speakers, presenting a challenge for data collection. Our objective is to make keyword spotting available for any keyword in any language. We have 1-second spoken word examples in 50 languages. We categorize each language based on the number of hours present in our dataset. For instance, we have over 100 hours of keyword data in 12 high-resource languages. In total, these 50 languages are currently estimated to be spoken by over 5 billion people. On average, each low-resource language has over 500 unique keywords and over 10,000 audio samples. For many languages, our dataset is the first publicly available keyword dataset. In total, our dataset contains 340,000 keywords with over 23 million samples and totaling over 6,000 hours of speech. We include open source tools for exploring the types of keywords present in our dataset in multiple languages. We include random samples here in English and Spanish, characterized by parts of speech tags and a Roberta-based zero-shot model for semantic keyword characterization. We also include predefined train dev and test splits for each keyword in our dataset, and we optimize for balanced genders and minimal speaker overlap between the train and test sets. We now briefly describe our dataset construction process. We derive our data from Mozilla Common Voice, a crowdsourced speech dataset. We automate the extraction of frequent keywords from sentence speech using forced alignment. By providing users with a massive keyword dataset, our data can be used to directly train keyword spotting models or to support transfer learning for fine-tuning models on keywords in languages which are not present in our dataset. Except for Chinese, we use a minimum character length of 3 as a coarse stopword filter for our inclusion criteria, and we ensure a minimum of 5 audio clips per word. Our keyword extraction pipeline ingests pairs of sentence audio and text transcripts. We use forced alignment to estimate per-word timing boundaries. We train our alignments directly on the data with no external acoustic models. Using the estimated timings, we apply our inclusion criteria and extract keywords into the dataset. These isolated keywords can then be used to train keyword spotting models. There are several potential sources of error in automated keyword extraction, such as transcript mismatches and estimated word boundary errors. Thus, we also provide a self-supervised nearest neighbor anomaly detection algorithm to automatically filter out erroneous samples using a distance metric. Evaluated on 75 keywords in English, Spanish, and German, we observe that an average of 23% of the furthest 50 clips sorted by distance are erroneous. Users of our dataset can tune their desired threshold for filtering. Our dataset includes all per-word timing estimates for Common Voice as Pratt text grids. We use the Opus compression format, and our total dataset size is 150 gigabytes. We evaluate the accuracy of keyword spotting models trained using our dataset. In particular, we consider the potential accuracy gap between models which are trained on extracted keyword data and models which are trained on individually recorded keyword samples. To do so, we compare our dataset to Google Speech Commands, a gold standard in keyword spotting research. This dataset provides 35 keywords in English and over 105,000 verified recording samples. We hold fixed a common keyword spotting model architecture and train 2 models, one using our data and another using Google Speech Commands data. We then evaluate both models on the test split of Google Speech Commands and observe an accuracy gap smaller than 7%. We also evaluate our dataset's suitability for few-shot transfer learning by fine-tuning an embedding model on just 5 training samples drawn from our dataset or Google Speech Commands respectively, and then again evaluate these models on the same test split from Google Speech Commands. We observe an accuracy gap here of approximately 4%. This suggests our dataset is well suited for keyword spotting applications in very low-resource languages. Our dataset will be maintained and updated by MLCommons.org and include additional languages and words over time. The dataset is free to download, easy to import, and licensed for both commercial and academic use. To summarize, we provide a multilingual spoken word dataset in 50 languages with full alignment data for Common Voice and data splits for reproducible experiments. We additionally open source our code and provide tutorial collab notebooks. Thank you.